In this system design, we tackle the architecture of a distributed, large-scale email service, similar in scope and complexity to platforms like Gmail, Outlook, or Yahoo Mail. An email service must ensure reliable message delivery, high availability, data integrity, fast search, spam protection, and real-time communication across billions of users and devices. Whether it's handling secure authentication, storing massive volumes of email data, or supporting features like conversation threads, attachments, and offline access, the system must be both robust and scalable. In the following sections, we'll break down this problem step by step, from understanding user requirements to designing the high-level system, walking through core data flows, and finally examining deep dive concerns like consistency, sharding, search indexing, and deliverability. The problem is to design a large-scale email service like Gmail and Yahoo. Here are some good requirement questions to ask. How many users are there? Can emails have attachments? How do users connect with mail servers? Do we need to worry about authentication? To build a robust and scalable email service like Gmail, we need to incorporate key components of traditional email infrastructure along with modern service-oriented elements. Let's walk through the high-level architecture. Email protocols. At the core, we rely on standard protocols. SMTP, Simple Mail Transfer Protocol, handles the sending of emails. POP, Post Office Protocol, and IMAP, Internet Message Access Protocol, are for receiving emails. POP downloads messages and removes them from the server, whereas IMAP keeps them on the server for access across multiple devices. These protocols ensure compatibility with desktop clients and mobile apps. Traditional mail server architecture. This consists of a mail transfer agent, MTA, for routing, mail delivery agent, MDA, for final delivery, and mail user agent, MUA, for user interaction. In our architecture, these are implemented as microservices, potentially containerized and orchestrated. Email APIs for web and mobile client integration. We expose RESTful APIs, post, messages, send an email, get, messages, retrieve all messages under a folder, get, folders, fetch all folders, e.g., inbox, sent, get, messages ID, retrieve a specific message. These APIs enable programmatic and browser-based interaction, essential for modern usage. Webmail interface users primarily interact with our system via a browser-based webmail front-end, supported by web servers that handle sign-up, login, and the above APIs. This separates the user interface logic from email processing and storage. Real-time servers. For immediate updates, like seeing a new email as soon as it arrives, we deploy real-time servers using technologies such as WebSocket or Server Sent Events, SSE. These maintain persistent connections with clients and push notifications when new emails arrive. Metadata database. This is a relational or NoSQL database that stores email metadata, sender, recipient, timestamps, folder info, read, unread status, while keeping the actual message body separate for flexibility. Attachment store file attachments are large and don't belong in a transactional database. Instead, we use object storage like Amazon S3, assigning each attachment a reference link stored alongside the metadata. Distributed cache. To reduce latency for common operations, like loading the most recent 50 emails in a folder, we introduce a distributed cache, e.g., Redis or Memcached. This cache is optimized using an LRU, least recently used strategy. Search store. For efficient searching of emails, we use a search engine like Elasticsearch or Solr, which builds inverted indexes of all email content and metadata. This supports fast queries on subject lines, senders, keywords, and even full-text body searches. In summary, this design combines the reliability of traditional email protocols with the scalability and responsiveness of modern web infrastructure, ensuring users have a smooth, secure, and real-time experience across all devices. Let's walk through how emails are sent and received in a high-level architecture for a service like Gmail. Email sending flow. The sending flow starts when a user composes an email and clicks the send button. This request is first handled by the load balancer, which distributes the traffic to one of the web servers for processing. At the web server level, we perform validation checks. For example, ensuring the email format is correct and confirming whether the recipient belongs to the same domain. If both sender and recipient share the same domain, we can short-circuit the flow. The email is immediately written to the sender's sent folder and the recipient's inbox, which means the email is instantly accessible via the client API. However, if the recipient is on a different domain, the web server pushes the email data into an outgoing queue. From here, SMTP workers read the message and initiate communication with the recipient's mail server using the SMTP protocol. During this process, the email is permanently stored in the sent folder for the sender. If validation fails at any point, perhaps due to bad headers, blacklisted domains, or malformed addresses, the email is sent to an error queue, where it can be retried later with back-off logic. Email receiving flow, now on the receiving side. When an email arrives, it first hits the SMTP load balancer, which distributes the traffic among a pool of SMTP servers. If the incoming email contains large attachments, those are offloaded to a blob store like Amazon S3, and only metadata or references are retained in the main email object. The incoming message is then placed into an email queue, where mail processing workers validate and filter the message. Filters might include spam detection, virus scanning, or policy enforcement. Once validated, the email is written into multiple storage layers: the mail storage database for long-term persistence, a distributed cache for fast access to recent emails, and an object store for attachments or large payloads. If the recipient is online, the system uses WebSocket-based real-time servers to push the new email notification to the client. These servers maintain persistent connections, allowing the client to get instant updates. For offline users, the emails simply sit in storage. When they come online and their client polls or refreshes, the webmail server pulls emails from the storage layer and serves them via the API. Let's dive deeper into some of the critical components that make a robust, scalable email service. 1. Metadata database design. Most user interactions, viewing inboxes, marking emails read, unread, deleting emails, operate on metadata, not the full content. So we prioritize this in our data model. Recency matters. Since users often interact with recent messages, we cluster emails by timestamp. High consistency is critical. Email is a reliability-sensitive domain. Losing an email is unacceptable. So we trade off availability for stronger consistency in our database. We use user ID as the partition key, ensuring all of a user's data lives on the same shard. This reduces cross-partition latency and makes queries like get all folders or get emails in a folder efficient. Inside each partition, we use timestamp as the clustering key to allow fast access to recent emails. For NoSQL systems, denormalized tables are necessary to support filtering operations, like unread, read status, or folder queries, efficiently. Conversation threads require special treatment, either thread IDs or recursive joins depending on the data store. 2. Email deliverability. Deliverability is a complex operational concern, especially at scale. Dedicated IPs help isolate traffic and protect sender reputation. Emails are classified and tracked for spam and abuse signals. We maintain a reputation score for each sender, banning spammy senders quickly. Implementing DKIM, SPF, and DMARC is essential to prevent spoofing and phishing. We also implement feedback loops to react to user complaints, e.g., marking as spam, and adjust the sender's privileges accordingly. 3. Search system. Fast, flexible search is crucial for a good email experience. We support text search, full body, subject, from, to, and filters, date, labels, etc. We have 2 main options. Use Elasticsearch, which is a common industry choice. It supports inverted indexing, relevancy ranking, and scales horizontally. Build a custom solution if we need tighter integration with metadata or want more control over resource usage. Whatever the solution, indexing happens during ingestion, so emails are searchable shortly after arrival. This deep dive highlights the core trade-offs. We optimize for consistency, metadata speed, and searchability, while keeping deliverability and reputation management as top-tier operational concerns.